You wake up, like any other day. Your phone is beside your bed. The screen lights up. Messages, time, weather, everything feels normal, quiet, controlled, predictable. Outside, the sun rises. You've seen it your whole life. A bright, warm disk in the sky. Harmless, it seems. Distant, just part of the background. But that light is not calm. It is a storm. The sun is not a peaceful ball of fire. It is a violent, boiling sphere of plasma, constantly twisting, snapping, and erupting. Magnetic fields knot and break apart. Energy builds for days, weeks, then releases in a single moment. And when it does, it doesn't just stay there. It travels. In 1859, something happened. Something so powerful that it reached across 150 million kilometers of empty space and touched the Earth. People didn't understand it at the time. They couldn't, and because the world was different then. No satellites, no power grids, no internet, no fragile web of electronics holding civilization together. But even in that simpler world, the sky caught fire. On the morning of September 1st, 1859, an English astronomer named Richard Carrington was watching the sun. Through his telescope, he saw a sudden flash of white light, a burst, bright enough to stand out against the sun itself. He didn't know it yet, but he had just witnessed the beginning of the most powerful solar storm ever recorded. Hours later, the Earth felt it. Telegraph systems, the most advanced technology of the time, began to fail. Wires sparked. Operators received electric shocks. Some machines caught fire, others continued working, even after being unplugged, powered by the energy flowing through the air itself. And then the sky changed. Auroras, the northern lights, appeared far beyond where they should, not just near the poles. They stretched across the sky, glowing red and green, visible as far south as the Caribbean. In some places, the night became so bright that people woke up thinking it was morning. Imagine that. You step outside in the middle of the night, and the sky is glowing, not softly, not gently, but alive, moving, burning with color, and you don't know why. That event is now called the Carrington event, a solar storm so strong that even today it stands unmatched. But here's the part that matters. In 1859, the world was barely connected. Today, everything is, and the sun hasn't changed. It is still there, still active, still capable of releasing that same energy, or more. The only thing that has changed is us. And if a storm like that hit Earth now, it wouldn't just light up the sky. It would reach into every system we depend on, every signal, every wire, every orbiting satellite, everything. So the question isn't whether it could happen again. It's this: what happens when it does? Start with something small. A compass, a simple needle floating freely, always pointing north. Quiet, reliable, invisible forces guiding it. That force comes from the Earth itself, the magnetic field, a protective bubble that surrounds the planet, stretching tens of thousands of kilometers into space. You don't see it, but it's always there, shielding you. Most of the time it works perfectly. But when the sun erupts, that shield is tested. A solar storm begins with a solar flare, a sudden release of energy on the sun's surface. In seconds, it can release as much energy as billions of nuclear bombs. That's not a metaphor, billions. Then comes something even more dangerous, a coronal mass ejection. A massive cloud of charged particles, billions of tons of plasma, hurled into space at speeds of up to 2,000 kilometers per second. At that speed, it crosses the distance from the sun to Earth in about 15 to 18 hours. No sound, no warning you can hear. just a wave of energy moving through the dark. When it reaches Earth, it doesn't hit the ground, not directly. It collides with the magnetic field. Imagine a storm hitting a wall. The wall bends, shakes, ripples. That's what happens to Earth's magnetic field during a powerful solar storm. It compresses on one side, stretches on the other, and begins to vibrate. Those vibrations send currents down into the Earth itself, into the ground, into long metal structures, into power lines. In 1859, this effect was enough to disrupt telegraph systems, wires that stretched across continents. But those wires were simple, sparse, limited. Now imagine something bigger. Today, the modern power grid spans entire countries. Thousands of kilometers of interconnected lines, transformers, and substations. And those systems are not designed for this kind of stress. A strong solar storm can induce currents strong enough to overload transformers, the heavy machines that regulate voltage in the grid. When they fail, they don't just switch off. They burn, and replacing them is not simple. Some transformers weigh hundreds of tons and take months, even years to build and install. Now multiply that across a continent. A single storm could knock out power for millions, not for hours, for months. That's the first crack, but it doesn't stop there. Look up. Orbiting the Earth right now are thousands of satellites. They guide planes, track weather, power GPS. Connect your phone to the world. They are exposed. A solar storm floods space with radiation. It can damage satellite electronics, disrupt signals, and in extreme cases, knock satellites out of orbit entirely by heating the upper atmosphere and increasing drag. In 2022, a relatively small solar event caused dozens of newly launched satellites to fail. They re-entered the atmosphere and burned up. That was small. Now imagine something like 1859. Navigation systems fail. Flights reroute or ground entirely. Communication becomes unreliable. Some areas lose it completely. And then there's GPS. You use it without thinking. Directions, timing, banking systems, power grids themselves rely on precise timing signals from satellites. Take that away, and systems begin to drift, slowly at first, then all at once. A delay of even a fraction of a second can cause failures in financial networks and communication systems. Time itself becomes uncertain. Here's a fact that lands harder than it sounds. Modern civilization depends on invisible signals more than physical structures. Not roads, not buildings, signals. And solar storms target exactly that. Now step back. In 1859, the storm arrived when humanity was barely connected. Its effects were strange, but limited. Today we are connected in ways that didn't exist even a few decades ago. The internet alone carries trillions of pieces of data every second. Under oceans, cables stretch for thousands of kilometers. Satellites fill the sky. Power grids hum constantly, balancing supply and demand. All of it works because it's stable, because the environment around Earth is stable. But a solar storm changes that environment. It turns space into a storm zone, and we are not outside it. We are inside. Here's the moment where it becomes personal. Imagine the power goes out, not just in your house, not just in your city, everywhere. At first, it feels temporary, like any outage. You wait. Minutes pass, then hours. Phones stop working. No signal, no updates, no way to check what's happening. Night falls, and the sky glows. Beautiful, terrifying. Days pass. Food supply chains begin to break. Stores empty. Water systems struggle. Hospitals switch to backup generators, but fuel is limited. There is no quick fix. Because the damage is not local, it is global, and repair depends on systems that are also down. Here's the gut punch. A study by the National Academy of Sciences estimated that a severe solar storm could cause trillions of dollars in damage and take years for full recovery. Years. Not because we don't know what to do, but because the scale is too large and the systems too interconnected. And yet, this is not rare in cosmic terms. The sun follows an approximately 11-year cycle of activity, peaks and lows, quiet periods and violent ones. The Carrington event happened near a peak. We are still within that cycle today. The sun is not done, and scientists have detected storms since 1859 that, while not hitting Earth directly, were just as powerful. They passed by us, missed us, barely, which leads to a question that hangs in the silence. If it happens again, will we be ready? Step back even further, beyond the power lines, beyond the satellites, beyond the fragile systems we've built. See the Earth as it really is, a small sphere wrapped in a thin atmosphere, protected by an invisible magnetic field, orbiting a star. That star is everything. It gives us light, heat, energy, life itself. Every plant, every breath, every drop of food energy begins there. Without the sun, there is nothing. And yet, the same star that makes life possible can disrupt the systems we depend on to live the way we do now. Not out of anger, not with intention, just by being what it is, a star. You are not separate from this system. You are inside it. Every second, the Earth is bathed in solar energy. Most of it passes quietly, unnoticed. The magnetic field deflects charged particles. The atmosphere absorbs radiation. A delicate balance, but not a guaranteed one. The Carrington event reminds us of something simple and uncomfortable. We live under a sky that can change, suddenly, and we cannot stop it. We can prepare. We can monitor the sun. Satellites watch for flares. Scientists track magnetic activity. Warnings can be issued hours in advance, but hours is not much time on a planetary scale, and preparation only goes so far, because the systems we've built are not designed for perfection. They are designed for normal conditions, and a storm like that is not normal. But here's the quiet part. This is not a story about destruction. It's a story about scale. The scale of the sun, the scale of space, the scale of forces that operate far beyond human control, and the scale of what we've built in comparison. You live in a time where information moves at the speed of light, where machines orbit the planet, where electricity flows constantly, invisibly, supporting every part of daily life. It feels permanent. It isn't. A single event, lasting just hours, could remind us of that. Not because we are weak, but because we are small. And yet, there is something else. Despite that scale, despite that vulnerability, we have learned to understand the sun, to predict its cycles, to build systems that, even if fragile, connect billions of people across the planet. That matters, because awareness changes how we respond. A storm like the one in 1859 would not arrive unnoticed today. We would see it coming, measure it, track its speed, prepare as much as possible. Lights might go out, signals might fade, but we would know why. And that knowledge is something humanity did not have before. Still, the question remains. Not about fear, but about perspective. When you look up at the sun tomorrow morning, it will look the same as it always has. Bright, distant, ordinary. You will feel its warmth. You will move through your day. Messages will send. Signals will flow. everything will work. Until, one day, it doesn't. And in that moment, the sky will remind us of something we spend most of our lives forgetting. That all of this, the power, the networks, the constant connection, exists under a star that does not notice us at all. And yet, everything we are depends on it.